Okay, in this lesson we're going to be looking at Unit 6, Chapter 6, Trigonometric Identities. We're going to be solving trigonometric equations using identities, Part 1. And we're going to look at solving trigonometric equations by graphing. So this again is from Section 6.4 in your text. And we're going to be focusing on solving trigonometric equations by graphing. Okay, to solve equations graphically. You've done this in the past. You've done it a number of times, in fact, in this course up to this point. And you've learned to solve equations graphically. And all we need to do is simply graph both sides of the equation and find the points of intersection of the two sides. So if you take this equation, for example, solve 2 cosine x equals 1, where x is between negative 90 and 360, including both negative 90 and 360. So we're asked to solve this graphically. All we need to do is we need to graph both sides of the equation. So you see that I've graphed y equals, and you can't quite see the tail of the y there, here we go, y equals 2 cosine x and y equals 1. So I've graphed the left side of the equation here, which is 2 cosine x, and I've also graphed the right side of the equation, which is y equals 1. So we got y equals 2 cosine x and y equals 1. Here's the graph of y equals 2 cosine x, graphed on my graphing calculator. And of course, here's the line y equals 1. All we're looking for is where the points of intersection occur. So we got a point of intersection occurring here, and here, and here. And these are our answers, because I'm only looking for the answers between negative 90 and 360. So between negative 90 and 360, again, we want answers in degrees. So we'll have an answer at, and you can see that these are multiples of 30, negative 30, negative 60, negative 90. So we get an answer at negative 60. We've got an answer again at 60. And we've got an answer again at 300. So there are our answers to the equation 2 cosine x equals 1 between negative 90 and 360. And again, we did it graphically. Now, we know you can do it algebraically, of course. But in this particular case, we are looking specifically at solving the equations graphically. Example 2. Solve the equation cosine squared x equals cotan x times sine x graphically in the domain between 0 and 360. Now again, look at your domain, because your domain in this case includes 0, because if 0 is less than or equal to x, is less than 360, but it doesn't include 360. So we're looking for the solution of this equation within this domain. Again, all we need to do is graph the left side of the equation, y equals cosine squared, and you see I've done that here in blue. Y equals cosine squared x is this graph right here. And I've graphed cotangent x times sine x in red. Now notice I've made a comment on the right here. Be careful of non-permissible values. Let's write what the solutions appear to be, at least from the graph, between 0 and 360. Our points of intersection occur at 0. They occur at 90. They occur at 270, and again at 360. Within this domain, of course, you should agree that we've only got 3 solutions. And that would be 0, 90, and 270. Because we know that x is between 0 and 360, but not including 360. So my answer of 360 is not a possible solution, because x cannot equal 360. It has to be less than 360. However, we must also consider, very important point in this example, we must also consider any non-permissible values. If we look at the equation, cosine squared equals cotangent x times sine x, you should agree that cotangent x, which is equal to cosine x over sine x, cotan x is undefined when cosine x is equal to 0. And sine x is equal to 0. So we just need to determine where is sine x equal to 0. Because wherever sine x is equal to 0, cotan x is undefined at that point. So that value of x cannot be considered as a solution. So where is sine x equal to 0? Well, let's think with the graph of sine x. The graph of sine x, and I just do a sketch here, looks like this, doesn't it? And if you think about the values of sine x, we got sine x is equal to 0 at 0, sine x is equal to 0 at 180, and again at 360. 0, 180, and 360 is where sine x is equal to 0. And we know that cotan is undefined at those values. So if you look at the three solutions that we had initially, and you look at where sine x cannot equal 0, sine x cannot equal to 0 when x is equal to 0, 180, and 360. You should see that there is a common solution here, 0 and 0. In actual fact, sine x cannot equal 0 at 0, because if sine x is 0, then cotan x is undefined. So our answer of 0 degrees is not a suitable answer, because it's a non-permissible value. For the exact reason that if sine x is equal to 0, the sine of 0 is 0. The cosine of x divided by 0 is undefined. So that is a non-permissible solution. So we have to ignore that solution. So the only two solutions are actually x equals 90 and 270. So we need to be careful, even graphically. When looking at the solution, we need to consider non-permissible values. So look at another example. You may want to pause the recording and try this one here, if you wish, on your own first. It says, use the graph shown to determine the solution to the equation sine 2x equals the root of 2 times the cosine of x over the domain between 0 and 360, including 0 and including 360. And you see that, again, I've graphed both equations here. Y equals sine 2x is graphed in blue, and the root of 2 times cosine x is graphed in red. So again, we're looking for the points of intersection. Points of intersection occur here, 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 and here, between 0 and 360. So my answers are going to be 45 degrees, 90 degrees, 135, and 270. Correct answer is A. All we're doing is looking for the points of intersection where the two graphs intersect. And let's have a look at one more example. This is going to be a short lesson. Here's our last example. Again, you may want to pause the recording and try this one on your own. Using the graph shown, determine the general solution to the equation sine 3x equals sine x. You will see that I've graphed sine 3x in blue, and I've graphed y equals sine x in red. And we're looking for the general solution this time for that equation. Notice this time it's the general solution. If we look at our answers, let's just list our answers first. We got 0 as an answer. We've got pi over 4 as an answer. We got 0, pi over 4. And this one here is going to be 3 pi over 4. Again, if you think about multiples of pi over 4, so 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, or pi. We've got 5 pi over 4 as an answer as well, right there. And we have an answer at 7 pi over 4 as well. And of course, we know that these values do continue in both directions. So I should put a dot, dot, dot on that side as well. We need to be able to look at those solutions now and determine which set or which answer on the left here, A, B, C, or D, would represent all of those answers. If you're looking for a single answer, it won't occur. Because you can see here, we started at 0, then went to pi over 4. The next multiple of pi over 4 is not a solution, so we just can't say pi over 4n. 0, pi over 4n would be pi over 4, then it would be pi over 2, then 3 pi over 4, and then pi, and so on. So this one here is missing, isn't it? So pi over 4n is not going to do it for us. So it has to be a combination of two solutions. And if you look at the fact that 0 is an answer, and pi is an answer, and 2 pi is also an answer, which I didn't list here, but 2 pi is also an answer. You can see that those three solutions, 0, pi, and 2 pi, maybe I should write my 2 pi in here. These three can be represented as x is equal to pi n, where n is the number of I. So there's one possibility. Now what about the other ones that are left? The other ones that are left start with pi over 4, then it's 3 pi over 4, 5 pi over 4, and 7 pi over 4. If you look at those answers, you should see that each of those answers are separated by 2 pi over 4 or pi over 2. So if we were to take the other 4 answers that are remaining here, that are listed at least, we can represent those as pi over 4 plus pi over 2 n, where n is the number of I. So my solution is B. Okay, as I said, this is a short lesson. To solve an equation graphically, we simply graph both sides of the equation and determine the points of intersection. Also worth noting here is that we should check that the solutions for an equation do not include non-permissible values from the original equation, as you saw in one example that I did. Okay, that ends this lesson.